What is going on, guys? Welcome back to a new tutorial series on the Neural 9 channel about SQL, or as some people like to call it, SQL, about the structured query language, the language that we use to work with databases and the data inside of databases, the language that we use to select data, to insert new data, to create tables, to connect them, to apply constraints to specific columns of tables and all that stuff, and of course a lot of more advanced stuff as well. And this is a fundamental skill for any programmer, but especially for data scientists, because we are working with databases all the time. When you do data science or machine learning, databases are at the core of it because data is at the core of it. And sometimes you will find data in CSV files, in Excel sheets, but a lot of times, most of the times I would argue, you will find data usually in databases. And this is something that you need to know about how to work with databases, and especially with relational databases, which are the most common databases. And this is why we're going to do this SQL or SQL tutorial series. So let us get right into it. Alright, now for this tutorial series, I would like to keep everything language independent and language neutral, meaning we're not going to focus on one specific implementation of a database system. We're not going to make this tutorial series about MySQL or about Postgres or about SQLite or something like that. We're going to learn SQL or SQL in general. I'm going to jump back and forth between the two pronunciations because both are correct. I like to usually call it SQL, but when I say something like MySQL, I like to say MySQL. Both are correct, so pronounce it however you like. But we're not going to focus on one specific implementation, one specific database system. We're going to learn SQL in general, and most of it is basically the same in the different implementations. So when I show you something in MySQL, you will probably be able to, maybe with some minor changes, run the same thing in Postgres or in SQLite. So this is for the most part, this is a language or dialect independent, dialect neutral tutorial, I should say. However, we still need to go with an implementation because I don't want to just write the code in a text editor and never run it. And because of that, we're going to go with MySQL because it's very beginner friendly, very simple. And how you install MySQL depends on your operating system. You just have to go to downloads and follow the instruction essentially. I think you're intelligent enough to figure it out for your specific operating system. So if you have macOS, just Google how to install MySQL on macOS. On Windows, I think the installation is quite simple. I will briefly show you how to do it on Linux, or at least on Ubuntu-based systems. Now, some of you guys are not going to like this because I installed it using Snap. So what you do is you basically say sudo apt install MySQL server. So sudo apt install MySQL-server, and this is basically just the database server. And then the tool that I'm working with here for this tutorial series is the MySQL Workbench. You don't have to use this tool. You can also use dbeaver, or you can use DataGrip from JetBrains if you have the premium version, or if you pay for it, or if you are a student, or if you have a trial version, whatever. Use the software that you want. I'm going to use MySQL Workbench because it's just the most convenient choice for making a tutorial. I would never use this editor because it doesn't support Vim bindings, but for the tutorial, I'm going to just use the MySQL Workbench. And to install it, what we need to do is we need to say sudo snap install MySQL-workbench-community. In my case, it's already installed, so I'm not going to run that. And then what you can do is you can run the service. So sudo systemctl start MySQL or MySQL.service. In my case, it should already be running, so this is not necessary. And then what you want to do, at least on Linux systems, I'm not sure if this is necessary on Windows and Mac, but what I had to do is I had to do sudo MySQL, and then when I'm inside, I had to set a root password. So I had to basically, let me just copy this here so that I can show you the command. Like this. I had to run this statement in the MySQL prompt. So you say sudo MySQL and then alter user root at localhost identified with MySQL native password by, and then you can choose a password. I chose password here. And the important thing now is that once you run this and then you exit from the MySQL shell, what you need to do is you need to open the MySQL Workbench. And here you have your connection, and you need to edit this connection so that the password that you're setting here is password. So you set this to password, and then you can just click on it. And here I have my prepared videos. You're going to see what they're about in the future episodes. But this is now the MySQL workbench connected to your database, to your MySQL database. And this is what you need as a setup here. Now, I trust you to be intelligent enough and capable enough to figure out the steps in between if something goes wrong, if you get some error message, if you don't have privileges, if things change a year from now, which is likely to happen, that you can Google your way around into the installation so that you get this running on your system, whatever the system is. So I don't want to focus too much on this. I want to focus on SQL itself, especially because this tutorial is not about MySQL, but about SQL in general. So I don't want to spend too much time here talking about the specifics of installing MySQL. Yeah, so the basic thing that we have here, I already have a database here that I use to prepare the videos. What you have here by default is you have some MySQL server with databases. And if you want to see what databases there are by default, you can just go and say show and then databases. And then you use a semicolon to terminate this line to say, okay, this is now the end of the command. And then you can click on this Thunderbolt button here to run this statement. So you can click on this and you can see that first of all, and by the way, if this is somehow not visible, you probably have to drag it from the bottom like this, drag it up from the bottom like this. You're going to see that this action was executed successfully. This is what you get down below here. And you can see here the result of running this command. And in my case, you can see I have this neural DB. You will not have such a database, but you will have information schema, MySQL, performance schema, and sys, at least in MySQL. This is going to differ probably between the different database systems that you use. But this command shows you what databases there are. Now, in databases, what we have is we have data, and the data is structured in rows, and those rows are located in tables, and those tables are in a database. So the basic structure is you have a database. In this database, you have different tables being somewhat connected or also independent. In those tables, you have different columns, different attributes, you could say, and one row filling the values of these different columns is one data entry, one piece of data in the database. So again, databases, inside of those databases, tables, inside of those tables, columns and rows. And they can be connected. So in this video today, in the first episode here, I want to talk about the very basics of SQL. So the very basics of creating a database, creating a table in that database, defining the different columns of that table, and then adding some data into that table, and then querying the data out of the table. So going through the basic process of using databases. So the first thing that we want to do is we want to say create database. And then we can pick a name for the database. So for example, tutorial DB. And always end the command with a semicolon. So create database tutorial DB will now create a new database. What you can also add here to make this less prone to errors is you can say create database if not exists. And what you will notice here is that SQL is very much like the English language. So you can just tell it what to do. You say create a database if it does not exist, tutorial DB. And the reason you want to add this if not exists is because in this way, if I run this command, and I can also run a command by holding Control and pressing Enter. So Control Enter will run this line, and you can see it created a database tutorial DB. I can now run this show database command again, and you can see we have this tutorial DB down here. And the reason we have this if not exists is because if I run this now again, you can see that I get a warning, but I don't get an error. So it says, okay, the command was executed, but this database already exists. Whereas if I remove this, if I just say create database tutorial DB, you can see I get an error that tells me that it cannot create a database. So this is just a nice way of not worrying about executing the command again if it was already executed. So now we have this database, but this database is empty. We don't have anything in it. And we can see that this is the case by showing the tables that are part of that database. But before we can run the show tables command, we need to actually say that we want to use this database. As you saw, we have 5 different, or in my case now 6 different databases here. And when we do something like show tables, we need to specify which database we're actually using to see the tables. So we can say here use and then tutorial DB to say that we're actually using tutorial DB. You can see this executed successfully, and now I can say show tables. And the reason I'm writing in uppercase, by the way, is just because this is how you usually write SQL code. There's nothing that prevents you from just saying show tables like this. It's not wrong. So you're not going to get an error if you write it like that. But when you look at code examples, you will always see the SQL statements being written in uppercase. So I like to do that as well. Show tables, and then you can see we have no tables here. So tables in tutorial DB, we have no entries here. So what we can do now is we can create a new table. And we do that, guess what, with the command create table. And we can also again say if not exists, so that I can run the command multiple times and it will not crash because the table already exists. So create table if not exists, and let's go with people, for example. So create table if not exists people, and now what we need to do here in this create statement is we need to say, okay, what kind of attributes, what columns are going to be part of that people table. So when I have a person, what attributes am I going to have for a person? And for this, we use these parentheses here. And again, we separate, we end the line or the command with a semicolon. And in between those parentheses here now, we specify the different fields. So for example, we can say a person has an ID, a unique identifier. So I can say P underscore ID. You can call this whatever you want. You can also call it this if you want to. So there's no convention here that you have to follow, otherwise it won't execute. But it's a good practice, depending on what you're working on and what code base you're working with, that you do something like P underscore for people underscore and then PID, or actually P underscore ID would be enough in this case. So what we need to specify now for this PID is what is it actually? So a data type. We need to say, okay, this PID is an integer, and you can say that it's an integer by saying int or by saying integer. Doesn't really matter. It's basically the same. So now we have this PID, which is an integer, and now we can add some other information about it. So for example, we can say that it's unique. We can say it's not allowed to be null. And we're going to talk about these constraints in a future video, but one of the constraints that we need to talk about here right now is the primary key. So we need to say that this is a primary key, and the reason for that is because every table or every row in a table needs to have a unique identifier. And the primary key basically just says this attribute here is unique and it is not allowed to be null. So it can't be empty and it can't have duplicates, which means every single row is going to have a value for PID and no two rows are going to have the same values. So because of that, we have now a unique identifier, which is called the primary key. And this is going to be interesting and relevant when we have also foreign keys later on referencing that primary key to make connections. But this is something that we're going to talk about in one of the later videos in this series. Now we're going to just say, okay, we have this PID, which is the unique identifier for a person. If you don't want to call this ID, you can also use something like social security number. In this case, we would use a different data type probably. So we could say the social security number of a person is a text, or maybe text is too large. Let's go with a character of size 32. So we have the social security number is a string of length 32, and this is the unique identifier because no two people will have the same social security number. So we're going to stick with the ID for now, but this is also a possibility. Now, talking about the data types, let me just briefly go through most of them, or to the most important ones, so that we have this covered for the sake of completeness. A field can be an integer, a field can be a character, as I showed you. So character would be fixed size, usually also faster than the alternative of the variable character, where we have essentially a character, but it's of variable size, meaning the 32 indicates the maximum size, but not the actual size. So it's not like this is always going to be of length 32. It can also be of length 15, but the max size is going to be 32. And then we also have the text, and the text is essentially for very long texts, you could say. So character when you have a small predictable size, variable character when you have to have room for a lot of text, but you don't need all of the text necessarily, and text when you have large text. Then we also have enumerations. Enumerations are essentially enumeration of values. So we have a certain number of values that are possible. For example, we could say favorite programming language can be C++, can be Java, or can be Python. And this is basically like a string then, but we cannot add something like Go to this list. And then we also have stuff like float, stuff like double, and stuff like decimal, where we can specify also the decimal places. And what else do we have? We have Boolean data types, basically true or false values. And then we have also date and time and date time and timestamps. Now, the reason I'm going through this quite quickly is because I don't want to show you examples for every single data type. We're going to use some of them as we go on with this tutorial series. We don't have to go through examples for every single one of them now. But essentially those are the most important data types. So you can store different types of information in a database. So let us move on now with the name, which is going to be a variable character of, let's say, size 255. And then we're going to have h, which is going to be an integer. And then we're going to have height, which is going to be float, for example. So this is how we create a table. We say create table if not exists. The table is called people. We have 4 columns in that table, and those are the data types, and this is also primary key. Now I can run this. Then I can say show tables, and you can see we have a people table. That is what we just created. Now this people table is empty, and we can see that it is empty by trying to select everything from that table. So there is a statement in SQL which is called the select statement, and what you do essentially is you specify which columns you want to select. So you say select PID, PName, PH, PHeight, or just PName, PH, or simply you can say everything. So you can say select asterisk and then from, because you can have multiple tables, from people, for example. And this would give me all the data that is in the people table. In this case we have, oh, did I change something right now? Let me run this again. Oh, this one actually. There you go. So we have PID, PName, PH, PHeight. We can see the column structure, but there's no data in here, so we don't have anything here. Those are just null values. So what we can do now is we can insert data into this table. And how do we do that? Guess what? Insert into. Then we need to say people. And then we have 2 options. Either we're going to specify all the attribute values or just some of them. Because remember, the PID has to be specified. It cannot be null. But I can leave out all of these values. So I can also say just a name and an ID, and I don't need to care about age and height. If I want to limit myself to certain fields, I have to specify which ones I'm filling in parentheses. So I need to say, okay, I'm inserting into people a PID and a PName, and not anything else. And then this is followed by the values keyword. And then I use, again, parentheses followed by a semicolon to say what kind of values am I actually putting into the table now. And I could start with something like ID1 and name Mike. And I can run this. And when I run this, I can call this select from people, select everything from people statement again. And you can see I have ID1 Mike. I can also go ahead and get rid of all this. And I can say insert into people values. Now, if I do it like that, I have to provide all the fields. If I don't limit myself to specific fields explicitly, I need to provide all of the fields, otherwise it's not going to accept that. So I can say here to John, and then John is going to be 78, and he's going to have a height of 180 centimeters. Insert, select, and you can see now we have Mike and John with all the data. As I said, since we have this as a primary key, we cannot just specify everything else. So I cannot just say pname, ph, p height, and then omit this ID, because in this case we would get this error message that the field PID doesn't have a default value, and it's also primary key, so we cannot just insert without it. Yeah. So that's basically the insert command. Now, what else can we do? We can also, of course, this is important, I didn't mention this explicitly, we can of course also insert multiple instances here, or multiple rows in one command. So I can say here PID again, but this is a valid command again, and then I can just list a couple of those insert rows like this. And of course, we're going to need a comma here to separate them. And in the end, again, a semicolon. But this is how you can also do it. So you can say here 3, 4, 5, 6, 7, 8. And then we can say Anna. We can say Bob. We can say Kate. We can say James, Samuel, and Lisa. Something like this. And then we can change the values here. And we can also change the sizes a little bit. Like this. Yeah, so we can run this, and we can select again everything from people. And there you go, we have all the data now in the database. Which brings us to the next point. How can I not select everything, but just specific rows? And I'm not talking about specific columns here, because we said already how we can do that. I can also say pname and ph to only get name and age as a result here. But how do I select, for example, only those that are older than 40 years, for example? Would make sense in this case. This is where the where clause comes into play. So I can say select p, name, and age from people, and I can attach here a where statement where the age is above, and I can just use the simple above or greater than operator here, 30. And I can run this, and you can see here I only get the entries where I'm above 30, or I can say 40, and then I'm only going to get those above 40. And this works also with less than. This works also with equal, so I can go and say equals 38. Then I'm going to get only those that are exactly 38 years old. I can go and say not equal 38, which is done like this, as you can see. And I can also say that I want to have where age is not null, because I think we have here, if I run this again, we have one instance where we have no age, which is Mike. I can also say where p underscore age is not null, and then I'm not going to get Mike. Yeah, so that is that. What we can also do is we can also filter based on attributes that we're not displaying. So I can say, give me name and age where the height of the person is above 180 centimeters. There you go. All right. I think that's it. One more thing maybe that could be interesting is we want to show, for example, combinations here. So we want to say, give me the name and age where the people are taller than 180 and their age is above 40, for example. Then we only get Kate and James. Or I can say, or where the age is above 40. So in this case, we would get... who did we get here? John? Was it John? How tall is John? Let me just see. Yeah, so even though John is not above 180, we still get John because he's above 40, and or means that, that we get when one of the two is, at least one of the two is fulfilled. We can also say XOR to get only when either or. So only when the height is above 180 or when the age is above 40, but not when both is the case. So those are just the logical combinations here. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.